Okay, so welcome to the lecture 2. So in this lecture, we'll talk about how can we model an AI problem as a search problem, and then we'll also talk about how we'll talk about a general strategy to solve that problem. So let's talk about let's take a problem which we usually face as an example, and then see whether we can solve it using AI or not. So we all face the problem of going from one place to somewhere else, right? For example, you want to go from place A to place B. So we all know, right? In our daily life, we do travel by, by a feet, by a car, or auto, or by something. Right? तो सपोज आपको प्लेस ए से प्लेस बी तक जाना है and now we want to develop an AI system which can does the same thing. For example, from location A to location B, we want our AI system to go from location A to location B. How it is going? Let's suppose it's going by a car. We can handle this. ठीक है? Let's suppose we can make this assumption our AI system is going from location A to location B. Now, how can we do this? How can we model this problem? For example, let's take a more specific example. Let me give you an suppose this map that you are seeing. This map is of Romania. It's a nice city, of nice country, but unfortunately, only our AI agent will get to go there, not us. So what we want, we want our AI's model from city A or city Arad to from city Arad to go to city B or city Bucharest. So where is this Bucharest city? City Bucharest. So we want our AI to go from city A to city B. So this is the problem that we want to solve. So let's suppose what do we mean by our AI system? Let's suppose it's a self-driving car. The AI system we are talking about is a self-driving car. So which wants to drive from city A, Arad, to city B. So how can we model this? So let's suppose city A से city A is a large city, so उसमें भी city A में भी कहीं एक पर्टिकुलर जगह पे होगा एंड वहां से city B तक जाने के लिए what it needs to do. So if you think about it and a little in more detail because now there are many things कि जैसे मान लेते हैं अगर यहाँ पे है तो which in which direction to go. For example, यहाँ से इस साइड जाना है या फिर इस साइड जाना है, इस साइड जाना है या फिर यहाँ पे जाना है. All these are decisions should be taken कि किस डायरेक्शन में जाना है, कितने स्टेप्स चलने हैं या फिर कितने kilometers, what should be the speed, and what's the condition of roads and so on. So there are, if you think about it, and we like micro detail everything, then we are in a trouble because, like for example, road condition or right. So this road condition or if you talk about something else like status of traffic lights, traffic itself, like other drivers, other vehicles are there, how much many vehicles are there, and so on. Speed, then their directions. So if we start thinking about these things, then we'll never be able to get out of the parking garage itself because now everything, if we micromanage everything, then there are lots of things to consider. Like we need to program everything. If steering को इतना turn करना है, so that we can turn on right or left. Our brakes should be pressed this much. Our speed or accelerator should be pressed this much, and so on. So these, and we, if you start going on this downhill of this too many details, then it's a mess. It's a really mess. So we don't want to worry about. Our goal is ki we want our AI system to go from city A to city B. And now, of course, these things that we have listed down here, these are important, and someone needs to be take care. Someone need to take care of these. But let so this system will take care of these, but not exactly not the details we are trying to focus on right now. We are trying to focus on what are the sort of decisions our agent should take to reach from here to here. So, for example, set of actions it should take to reach from city A to city B. We don't care about the specifics of these road condition and all this. We only care about कि यहाँ से next को कहाँ पे जाए. That's the concern. वहाँ पे जाने तक का exact details that agent can figure out, or the program part of the agent that can consider these. कि for example, जैसे self driving car है तो it would have learned from the past experience using machine learning and computer vision and all this. So these brain it has to keep track of these things. But the thing we are working on is कि जैसे यहाँ city A है तो which city it should go next, and for example it goes from here to here, then यहाँ से then which city to go, then it can, let's say it can go to here, then next it can go here, then here, something like this, here, and then here. So or simply it can go here, here, and here. So we are only worrying about the path it should choose to go from city A to city B. We are not worrying about the exact details of road condition, traffic lights, how much traffic is there, what speed should it maintain. So we that these are the details which can be modeled inside the AI system based on how it learned to drive. So these are more specific to how to drive. Right. So we right now we are if it's an AI agent which can drive us. Also, we are working with this assumption that our agent is able to drive the car itself. It just doesn't know the path. So our goal is to help AI agent to find a path from city A to city B, not the exact key. We are not trying to teach our AI agent of like how to drive a car or not. That's not our goal. So how can we model this problem as a, so how can we avoid these getting into these too much details and make an abstract model out of this problem so that we can easily solve that problem as a search problem and search for a path from start to no goal. So this is the start and this is our goal. So our goal, so what's the purpose here? Our agent will start from here to here. So and reach, that's the entire goal, right? We are not worrying about these too much abstraction or too much details of the. So let's abstract out the details. So what's our what are the things that is our requirements here is ki we can model our cities as like a single nodes. There is the city A, then there is the city B, which is connected to city A, and these these are the cities which are connected to A. So from the start, so यहाँ से it can go to this city, this city, this city. Now inside this city, how to drive or how to drive over these roads, this is not what we are worrying about. We are kind of like abstracting out those details for our problem to simplify our assumptions or simplify our problems. ठीक है? Of course, agent need to be worried about those, but this can like we are working with this assumption. Okay, agent already knows how to handle the speeds, how to handle the brakes, how to drive from one point, how to turn the wheel, steering, and so on. Then, so to simplify our model for this Romania example, where we want to our agent to start from Arad city Arad to end to reach city Bucharest. So what can we do? We can simply abstract out the details and we can plot something like this, right? There is this start from where we are starting our AI agent is starting initially initial position of our start, and this is our goal. So we can represent these cities as a different states. If I just remove all these, so we can represent these cities as a state. So this is one state, this is another state, so, and इसके भी जो भी neighbors है, this is another state, and this is another state. So this can be like state 1, this is state 2, state 3. These states are key. These what are these states? These states are simply the our environment state key right now how our environment looks like. So environment is simply the surroundings where agent is working on. So this is the our environment right now. That तो initially environment क्या था जहाँ पे agent था that initially environment was here, right? AI agent was there in the city A. So this was the current state of our environment. Ki agent is in the city Ara. Now if a so state simply represents the current position or current circumstances of the circumstance of the environment. So you can think of state representing as a current situation of in not in like current itself key just one situation of the one possible combination you can think or yeah one combination of how environment looks like a combination or one permutation or how our environment how environment in which agent is working look like at that point. So that is what our state represents exactly. Depending up, तो for example at this point की जैसे agent is in the city Arad, so this is one state of the environment ki this right now state is city Arad. If agent travels from Arad to city as CBU, so now our state becomes the CBU, right? So this is the so now we can simply model our problem as a graph of states where each state is connected to the other states which can be generated from this state. So how to generate these states? These states are generated using something called a transition model. So for example, city A, if we right now agent is in the city A, so this is the current state. Now, what are the actions possible for the agent? It can move to any of the neighboring city. So it can either go to S, CBU, O, Oridia, or Timisoara T. So it has three actions possible. So it can go action 1, action 2, action 3. So what are these actions? Actions are simple. So the actions are possible moves an AI agent can take in current city in a state. तो जैसे अगर आराध में है तो it can either go to right. तो जैसे तो this A1 what will this A1 will be go to CBU. Yeah. So this action A will be go to CBU and जैसे ये अगर ये action choose करता है तो now the our state will become CBU and जैसे action 2 क्या हो सकता है यहाँ पे can we go to Timisoara. So if this action is taken then our state will become right और तीसरा go to Oridia right, Oridia. So now the state will become Oridia. So actions are the possible moves which can be taken in a state and तो किसी state पे given a state and an action जो output जो आ रहा है which will be an another state S prime you can think of it. तो given a state and an action जो output generate रहा है this is defined by something called transition model. जैसे यहाँ पे this is what our transition model is. The state was A and the actions were go to CVU, go to Timisoara, go to India, and based on that, whatever state is being generated, these are what our these are defined by our transition model. Okay. So transition model you can think of as a function like can be Auto as a function, as a function which takes the this as an input and this gives a output. Okay. So now since what, so जैसे what's the action here, this will you go to CB. अब अगर ये एक्शन लेते हैं तो एजेंट नीड टू पे सम कॉस्ट फॉर दिस की, बिकॉज यहाँ से यहाँ तक ट्रेवल करने के लिए एजेंट को कुछ टाइम लगेगा या कुछ डिस्टेंस ट्रेवल करनी पड़ेगी। तो जो डिस्टेंस है दिस इज नोन एज अ पाथ कॉस्ट और an action cost, you can think of it. This is a cost associated to that action, right? So this can be distance or time taken or in some other problems we'll talk about the number of steps and so on. So this cost is for an agent is sorry cost associated to an action is कि उस एक्शन को जब एजेंट ने लिया तो उसे क्या cost पे करनी पड़ी, right? कि if it is like a traveling somewhere then the cost can be associated with the distance traveled, or if it is कि किसी काम को करने के लिए कुछ टाइम लग रहा है तो this cost can be associated with the time itself, और अगर कोई किसी और टाइप की प्रॉब्लम के बारे में हम डिस्कस कर रहे हैं तो then appropriate cost model can be defined. So this can be this depends upon the problem we are problem. For in this problem we are only discussing about the distance. Okay? So we have talked about what state is, what action is, what the transition model is, what cost is. We also talked about our goal. So goal क्या? Goal is simply goal state is like a how. So goal is simply goal test or goal. Reaching the goal state. So and जहाँ से जिस स्टेट से हम स्टार्ट कर रहे हैं तो जो स्टेट्स है देर आर टू स्पेशल स्टेट्स इन दिस, like one is the goal state, this is another special state, and this is initial state जहाँ से आपका एजेंट स्टार्ट हो रहा है. So we have defined the initial state, goal state, and all the collection of these states is known as a state space graph. So if I define the state space graph for this problem, it will look something like this. Right? So this is so here let's define all the things that we have discussed so far. So this will be my initial state. This will be my goal state. These numbers, this is the distance of this path और this distance of this trail. तो जैसे मान लो मुझे आर से बी तक जाना है तो one path possible path is this, go to R to go to S to F and F to B. एंड तो इस टोटल इस पाथ के लिए पाथ कॉस्ट क्या होगा, टोटल कॉस्ट जो इस एजेंट को पे करना पड़ा दैट विल बी 140 प्लस 99 प्लस 211. तो दिस इज कॉल्ड पाथ कॉस्ट कि उस अगर एजेंट ने स्टार्टिंग स्टेट से और इनिशियल स्टेट से गोल तक जाने के लिए जो पाथ लिया है उस पाथ पे जितना कॉस्ट उसने पे किया है हर एक्शन के करस्पॉन्डिंग, तो जो ये दिस वाज द एक्शन 1 जो उसने टेक, या दिस वाज द एक्शन 2, दिस वाज एक्शन 3, तो उस एक्शन हर एक्शन के लिए जो कॉस्ट उसने पे किया है sum of all these cost is defined as the path cost. So path cost can be defined as a sum of all sum of costs for all the actions taken by agent to reach goal goal from starting state. Initial plus start state. Okay, so this is path cost. So we have talked about path cost, we talked about initial state, goal state. This entire thing is known as a state space graph. It's a simple collection of all states. All states which are generated by our transition model. Transition model or transition function. So to model our AI problem into a search problem, because now since this is a simple graph and you can use any search algorithms that we have studied like DFS to search for path from city A to city B. And we'll talk about these algorithms, DFS, and many other algorithms to search for this particular path. So if we can model our any problem as a search problem and represent it using a state space graph, then we can look into this state space graph and search for a path from the initial state to goal state. And that path will give us the solution. Right? So this path is the solution for us. This path जो हमने find किया, this is the solution for us. This is the solution which we wanted to find for our AI problem. Because what was our AI problem? Ki our agent wanted to go from city A to city B. So we just needed to find a path for him, for it to take, from which it can take to reach from start to the goal step. So now that we have found a path, this will be our solution. Now, since our AI agent already knows how to drive a car, and now it knows कि सिटी ऐसे कौन सी नेक्स्ट सिटी में जाना है, वहां से कौन सी नेक्स्ट सिटी में जाना है, एंड वहां से कौन सी सिटी पे जाना to reach our goal node Bucharest. So now that we have found solution, it can be used by our AI agent to reach from city A to city B. So to model our any AI problem, which we'll talk about lots of AI problems, and we'll model those as a search problems, and we'll use these search algorithms to find solutions for this. We to model any AI problem into the search problem, we need to define few things, and these few things are state space graph, initial state space graph, initial state, actions, transition model, goal test, and path cost function. So to model AI problem, we need to define following things. These following things are state space graph, initial state, actions, transition model, goal test, and path. We already know what these things are individually. State space graph is simply collection of all the state which can be generated by our transition model. Initial state is starting position of the starting position of our AI agent. Actions are the possible moves In a state transition model, it can be defined as a function which takes current state as input and the action current state and action as input and gives the next state which can be generated और next state जैसे यहाँ पे एक रैखिक एग्जांपल में ले तो current state will be R and action will be go to CBU and if these so what will be the state then CBU because now your agent will be in CBU. So this is one transition model. Goal test is way of goal test. What is goal test? How to check way of checking whether we have reached the goal. So goal test is simply way to identify or check whether AI agent has reached goal reached goal state or not. Right? So we can simply check कि जो state आ रही है that is equal to the Bucharest or not and that will be it. Path cost function simply cost associated with each action. So to define our AI problem into search problem, we'll just need to define these 6 things, and that's all there is to it. So if we have modeled our AI problem as a search problem, then we can simply use a general search strategy like BFS, DFS, or any other that we'll talk about in the future lectures, and find us a solution, a solution for our agent which can be used to solve the problem. So, for example, this is a example of 8 puzzle problem. Sorry, this is an 8 puzzle problem. So, what is this problem exactly? कि you are given a board जिस पे 8 9 cells है और उन cells में there are like 8 puzzles given और 8 numbers 8 tiles वहाँ पे given है और हर tile पे एक number associated. तो as you can see this is a 3x3 board जहाँ पे 9 cells है एंड हर सेल में एक टाइल रखी हुई है उस टाइल पे एक नंबर एसोसिएटेड है these are the tiles. तो व्हाट्स आवर गोल इनटू दिस कि इनिशियली ये टाइल्स किसी भी ऑर्डर में हो सकते हैं जैसे यहाँ पे 1 यहाँ पे 7 यहाँ पे 2 यहाँ पे 4 यहाँ पे एंड सो किसी भी ऑर्डर में हो सकते हैं एंड आवर गोल इज तो यहाँ पे ऐसे हो सकते तो होता क्या है कि जैसे यहाँ पे एक ब्लैंक स्पेस है व्हाट यू कैन डू यू कैन स्लाइड दिस टाइल हेयर तो अगर इस टाइल को यहाँ पे स्लाइड कर दोगे तो 5 विल कम हेयर एंड दिस विल बिकम अ ब्लैंक स्पेस और सिमिलरली अगर आप 3 को यहाँ पे स्लाइड करते हो तो 3 विल कम हेयर एंड दिस विल बिकम द ब्लैंक स्पेस बिकॉज नाउ ब्लैंक विल मूव एंड सेम गोज फॉर दिस ऑल्सो कि 6 को आप अगर यहाँ पे कर देते हो तो 6 will come here and this will become the blank space. Same here. If you can 2 को यहाँ पे कर देते हो तो 2 will come here and blank space. तो possible so these are possible actions right which can be taken but this is not possible. You can't slide 4 here and 4 comes here and this is not possible. So diagonal moves are not allowed. Only either you can slide right, down, left and up. So, and what's our goal? We want to arrange all these tiles in an increasing order. So either we want to do this something like this, or we might want to do something like this also. The let's say this is 3 plus 3. So for example, I can do something like this also कि 1 यहाँ पे 2 यहाँ पे 3 यहाँ पे 4 यहाँ पे 5 यहाँ पे 6 7 and 8 and there is this blank space. So either we can do something like this or we can do something like this. So these two are both goal state. So this is another example key where one problem can have multiple goal states. This is our initial state or start state. And so now we want to model this problem as our search problem. And we want to use our search strategies to find a solution for it. Key. What's the solution? A path which can lead from here to here. We want to find a path जो कि इस initial state से goal state तक पहुंचा सके. So how can we model this as a search problem? Can we model 8 puzzle problem as a search problem? Hmm? तो हमने ये पढ़ा था कि सर्च प्रॉब्लम को किसी भी मॉडल उसको सर्च प्रॉब्लम में डिफाइन करने के लिए वी नीड 6 थिंग्स. फर्स्ट, initial state, which is already given to you. So initial state is this. It is given to you, so you can take this state as initial state. So we can define our initial state just like this. So let's define our initial state. So this is our initial state. Let's say 7, 2, 4, 5, blank, 6, 1, 3, and 8. So we have defined our initial state. What's the another thing that we need to define? Goal state or goal test. So what's the goal state? Simply either it is already given to you, so we can define take that as itself. So let's take that goal state itself. And so this is the blank. This is 1, 2, 3, 4, 5, 8. So we can consider that as a goal state. What other things that we need to define? So let's define all these things. Actions. What are the set of actions which are allowed in a step? So what are the different actions? Slide down left, slide tile left, slide tile right, slide tile up, slide tile down. So we can define as a slide tile up, slide tile down, slide tile left, and slide tile right. तो कुछ स्टेट्स में हो सकता है कुछ ही एक्शंस पॉसिबल हो, कुछ स्टेट्स में सारे एक्शंस पॉसिबल है। फॉर एग्जांपल अगर हम इस स्टेट की बात करें, गोल स्टेट की, तो यहाँ पे इधर वी कैन टेक स्लाइड दिस एज ए लेफ्ट और इधर वी कैन स्लाइड दिस एज ए तो अप, बट नॉट एनीथिंग एल्स। तो यहाँ पे सिर्फ दो एक्शंस पॉसिबल है, लेफ्ट वाला और अप वाला। तो कुछ स्टेट्स ऐसी होंगी जहाँ पे चारों एक्शंस पॉसिबल होंगे, कुछ स्टेट्स होंगे जहाँ पे कुछ एक एक्शन पॉसिबल होगा, किसी में दो एक्शंस पॉसिबल हो सकते हैं एंड सो ऑन। तो दिस कैन बी डिपेंडिंग अपॉन, बट इनसे ज्यादा नहीं होने वाले। ईच स्टेट कैन हैव ओनली फोर एक्शंस फॉर at max. So we have defined initial state, goal state, actions. Let's define our transition model. तो transition model कैसे define कर रहे थे? Transition model was simply a function which was taking state and action as input. This was input and was generating a output called state, next state, state prime. So, so this will give us lots of the one. For example, if I have to draw for this one, so I have this state, this state as input 7, 2, 4, 5, 6, 8, 3, 1, and this was the state and action क्या possible है? Let's suppose कि यहाँ पे तो चारों actions possible है, तो let's suppose कि slide tile up ये action में ले रहा हूँ, तो up कौन सा होगा? up कौन सा possible है? 3 को up में move करके and our blank space will move down. So what's the resulting state? The resulting state will be resulting state will look something like 7, because बाकी tiles की position change नहीं होंगी. Only thing which is gonna change is कि यहाँ पे now 3 will be here and blank will be here. Rest of the tiles will remain the same. So this is one transition model. You can think something like this also कि जैसे यहाँ पे instead of up, what if it action would have been कि slide tile left. अगर ये एक्शन होता तो लेफ्ट में क्या होता? We would have instead of like then left में क्या होता? 6 would move here. So now it would look something like 6 will be here. So 6 will be here and blank will be here and rest of the positions will be same. 7, 2, 4, 5, 8, 3, 1. Right? These will be just exactly same. So this is our transition model. You can define for you in the exams or whenever you ask, you don't have to define for every state. Just define this the general concept and then just give for one state only. One state and one actions you can give for all positions. And अगर actions बहुत ज़्यादा है तो but one or two actions के लिए you can draw the transition model and that will be enough for the exam. So we have defined our actions, transition model, initial state, goal test, and the what else do we need to define? We need to define So we need to define something called path cost function. तो cost यहाँ पे now it's up to you कि how you define the cost है because in like let's suppose जैसे मैं एक टाइल को स्लाइड कर रहा हूँ तो we can associate any amount of cost for that right और I can do कि हर एक्शन के लिए सिर्फ एक cost यूनिट cost हम अप्लाई कर सकते हैं तो we can do something like this कि unit cost one unit cost for each action right so this can be our path cost function कि जैसे यहाँ पे स्लाइड टाइल अप है तो जो भी स्टेट थी उसमें स्लाइड टाइल अप एक्शन लिया तो इट विल पे वन यूनिट ऑफ कॉस्ट एंड देन वट एवर रिजल्ट इट गोस तो दिस एंड अगर मैं स्लाइड टाइल लेफ्ट कर रहा हूँ it also it again will pay one unit of cost and it will generate another so we are defining as a, like one unit cost for each action so this is one possible action you can define separate one also कि लेफ्ट जा रहे हैं तो अलग कॉस्ट पे करनी पड़ रही है अप जा रहे हो तो अलग कॉस्ट पे करनी पड़ रही है लेफ्ट जा रहे राइट जा रहे हो तो अलग कॉस्ट डाउन जा रहे हो तो अलग कॉस्ट so that's completely up to you how you want to model your problem but in general if there is nothing just take the unit cost for your I'm saying for others okay so always go for unit cost अगर कुछ हर x for each action not for entire path one unit of cost for each action if nothing else is given to you ये जैसे पुरानी प्रॉब्लम में we were taking distance as a unit cost because distance was given but यहाँ पे there is no measure of distance if you don't want to go into much more details or want to complicate our problem there is no notion of distance so that's where we'll say कि ठीक है हर action के लिए we'll pay each one unit cost and that's all our path cost will be ठीक है so we have defined path cost the last thing that remained is state space graph so what's the state space graph it's state space graph is simply collection of all the states so we have one state say, two three so we can simply define as like they say it will be like lots of states in there so we don't want to define entire state space we can simply draw few states and that's all जैसे first state वाल जो first state हम जो discuss कर रहे थे that was okay let me just copy this initial state okay so let's use that as a initial state for us and this is the one step now इसके जो भी successors होंगे we can draw those and define those and edges between those right कि जैसे इसके जो भी successors थे what were those different successors for us एक में एक successor was this if I take this one also copy and paste it here there was one successor was this and another successor which let's copy it again and paste it here each ठीक है so what was this successor ये किस एक्शन की वजह से हुआ था स्लाइड टाइल up and what was the cost paid for it one similarly This was slide tile left and cost paid for it was also. ठीक है तो यहाँ से यहाँ तक जा सकते हैं तो दिस इज वन एज बिटवीन दिस टू बिकॉज दिस इज एन अनडायरेक्टेड एज बिकॉज यहाँ से अगर मैं इसका वापस एक एक्शन लूँ यहाँ से क्या एक्शंस पॉसिबल है अगर मैं यहाँ पे जा सकता हूँ वाया स्लाइड टाइल डाउन एक्शन लेके राइट सिमिलरली यहाँ से स्लाइड टाइल लेफ्ट राइट करके आई कैन अगेन गो टू दिस स्टेप दैट्स व्हाई आई हैव ड्रॉन दिस अनडायरेक्टेड एज एज और नाउ यू कैन गो फर्दर इसका भी एक एक्शन आप डिक्लेयर कर सकते हो you can define one action for it and you can create a state so for example यहाँ पे कौन कौन से actions possible है either you can move it here down to again it will reach to this one or either you can move it to here so let's do this one also second one also slide tile right and तो इसके लिए क्या एक्शन होगा वन कॉस्ट पे करनी पड़ेगी तो नाउ blank will be here blank will be here and 8 will be here rest of these states will rest of tiles will remain same so this is how you can create a state space graph इसके लिए भी आप you can create separate यहाँ पे और actions है तो उनके लिए यहाँ पे बना सकते हैं and this entire collection of this will become our state space graph so in the exams you don't have to draw this entire thing it will take lots of time you just draw few states and draw these edges and that will be all for the okay so now that we have defined everything to model our search problems our AI problems as a search problem so now we know that now let's talk about some strategies or general strategies of how we can find our solution so let's suppose so to find the general strategy that we are going to use is we'll start with the frontier this frontier is also known as open list this frontier will be a data structure a simple data structure so this data structures can be anything we'll talk about few common ones and uske according this algorithm will change so this is the general approach and depending upon what data structure we use will generate different type of strategies with different names so we'll start with the frontier which will contain the initial node or initial state and what after that what we'll do we'll pick one node from the frontier remove that node we'll check whether की तो अगर जैसे we'll start with the initial state and then we'll remove one node from the frontier and अगर वो node है तो we'll check whether this node is a goal node or not अगर goal node है तो we'll return the solution because we have found the goal and if that is not a goal node then we'll add all the successors or तो all the successors like this जो these states are known as the successor states जिस उसके लिए generate हो रही है वो so we'll add all these successors and into the frontier and then repeat the same process so let me give you an idea about it let me show you an example then it will be better to understand so let's suppose this is my state space graph if this is the state space graph this is my initial state and this is my goal state so what's our task here Ki we want to find a path from A to E so we have abstracted out all the details so now we are simply representing each state as a node in a graph and we want to find a solution तो व्हाट्स आवर सर्च स्ट्रेटजी? स्टार्ट विद द फ्रंटियर। इस फ्रंटियर का एक और नाम होता है, दैट इज ओपन लिस्ट। You might find that name itself. To start the frontier with that contains the initial state. So initially, we'll insert the initial state in the frontier. So let me insert the initial state A in the frontier. Now what we'll do? We'll repeat the same process. Repeat the same process. कब तक? तो it's like a loop. तो it's a loop, a while loop kind of thing. जिसकी condition है कि if frontier is empty, then we'll return कि we have not found the goal state because हमने सारे states explore कर लिए and तभी भी हमें कोई goal नहीं मिला. That means कि this is the problem where there is no solution for that. So there is no solution for that problem. For that problem, and will there might be lots of these problems where solution doesn't exist or we haven't found, or even if solution exists, it can't be reachable. It is not reachable from the start. For example, in start is A and there is the solution is goal state is something like this, which is not connected to the state space, or there are no actions which can lead us to the goal. So since this is not reachable, we can't find, or we can't find the solution. So then we'll have to return key solution doesn't exist for that problem. But that um, if if that is only if frontier is empty, अगर frontier empty नहीं है तो what we'll do? We'll remove a node from the frontier. So let's remove the node. Let's remove node A from the frontier. We have removed it. ठीक है? Remove and deleted. If the we'll check whether this node is a goal. So will by removing means कि I'm using a temp variable which will store our node जो भी हमने यहाँ पे वो किया है. So for example यहाँ पे क्या अभी था A. So this temp variable keeps storing A whenever we are coding it or writing a program for it. Now we'll check whether this A is a goal node or not. So is it a goal node? Is A? No, because goal node is E. A is this is not E. What we'll do? We'll expand the node. So what do you mean by expanding the node? Will we mean by expanding the node is कि A हमारा नोड है तो इसके जो भी एक्शंस पॉसिबल है, एक्शन A1 A2 A3 टिल An, जो भी एक्शंस पॉसिबल है इनको ट्रांजिशन मॉडल में डाल के जो भी सक्सेसर्स आ रहे हैं, जो भी स्टेट्स आ रहे हैं ऐसे इन सबको फ्रंटियर में ऐड करो. तो ऐड all the successor nodes in the frontier. ठीक है? तो जैसे A से कौन कौन से नोड्स पॉसिबल है? A से एक ही है, B, तो add B into the frontier. So let's add B into the frontier. ठीक है? Add resulting nodes in the frontier. Okay. Now again, so this was the last step in the loop. We'll again circle back to the loop. So again check with the frontier is empty. Is it empty? No, because there is B in the frontier. So what we'll do? Remove a node from the frontier. To remove B from the frontier. So let's remove B. So now our temp stores. Temp क्या store करेगा? B. Now temp B. If node contains a goal node, no, B is not equal to E. So अगर node होता तो we will return solution, but no. So what we'll do? Expand the B. B को expand करने के लिए क्या करना पड़ेगा? Again we'll fed B to the transition model with all the actions possible, and will generate all the successors of it. तो यहाँ पे क्या क्या successors है दीजिए, it is C and D only, right? So these are the only successors of it. So we'll add those back into the. So let's add C and D into the frontier. Now, now again go back to the front. No, frontier is empty. No, frontier में दो node है अभी. Remove a node from the frontier. Now there is a trick part. एक नोड रिमूव करना है हमें, सिर्फ दो नहीं. तो अगर एक नोड रिमूव करना है, but there are two choices, which one to pick, right? Which one to select? So this choice makes the various algorithms. अगर मैं जो नोड पहले गया है उसको पिक करता हूँ, that will result us into the BFS search algorithm, which will implement the frontier as a queue. एंड अगर जो बाद में गया है उसको पहले पिक करता हूँ, तो that will result into the frontier with the DFS, which will result into the search algorithm DFS, which uses the frontier as a stack. So stack as a frontier. Or if we assign some priority or some cost to all these, then we'll use priority queue as a frontier, and that will result into the other search algorithm called uniform cost search, and so on. So depending upon which frontier we use or which kind of data structure we use, this which node to pick can vary, and this will lead us to the inner search of many algorithms. So let's go with the first one itself right now. So let's pick the one which, so let's pick C. I will pick C. Remove a node, तो now B temp क्या store करेगा? C. Check whether this is a goal node or not. C is not a goal node. So what we'll do? So we'll simply expand the node. So C transition model से क्या generate होगा? E. Add E into the frontier. So add E into the frontier. Now again pick one. So pick D. D pick work. Is it a goal node? No. So again let's go with the same process. D get F generate work. Add F into the frontier. Pick again E. E pick work. So now this contains E. Now if node contains, now this line will true because now E is the goal. If this is a goal, then return the solution, and we'll return the solution. What will be the solution? Solution will be the path from initial state to goal state. So what will be the path? A, B, C to E. This is the solution. And जैसे solution मिला, and this will what it will do? It will terminate. It will terminate the algorithm. So as you can see, even though there is this F inside the frontier, still it will never be explored because we have found the solution before that. So this is how our search strategies work. We'll talk about these in a much more detail of like with the specific frontier from the next lecture key, where to use like a specific implementation for the frontier. We'll use various data structures this is a general search strategy. But do you think there is a problem with it? So let's talk about one problem that we haven't really solved and that kind of makes our strategies much more efficient. So right now, our algorithms might suffer with a problem which is not hard to deal with. So let's deal with that problem. What if our search space is like this? So what will happen? We'll start with A. The frontier will contain the initial state. The initial state, and so then what we'll do? Repeat. If frontier is empty, frontier is not empty. Right? Frontier contains A. So we'll remove A. Will temp equal to A. Now we'll expand A. तो A को expand करने के लिए क्या होगा? A के जो भी successor थे, A से जो भी actions possible है, action से A की action possible है, which will result into the transition model, resulting into B. So we'll add B into the frontier. So let's add B into the frontier. So now B has been added into the frontier. Again, we'll repeat the same process. If the B, whether B will remove B from the frontier. So let's remove B. We will check whether B is a goal state or not. Not B is not a goal state. Goal state is E, right? This is goal, and this is initial state. So B is not a goal state, so we'll expand the B. So let's expand B. This is B. तो इसमें कौन कौन से actions possible है? There are two actions possible, three actions possible exactly. Either it can go this, either it can go this way, or again go that way itself. Now you must be seeing the problems, right? तो तीन actions possible है, action 1, action 2, action 3. action 1 क्या lead कर रहा है? A पे. action B is leading, action 2 is leading C, action 2 is leading to D. And now again we, according to our algorithm, will repeat again, insert all these successors. So insert all successors in frontier. So if I insert, the B has been removed, right? B has been removed. Insert all, to insert A, C, D. Insert कर दिया. Now again what we'll do? Remove A. Now you must be saying कि A already explore हो गया था, फिर भी हम उसको बार बार explore कर रहे हैं. तो again we'll explore A. अगर A को explore कर रहे हैं तो क्या problem आ सकती है? Again we'll work with this कि A को जैसे explore किया, A will again lead to the B. So we need to insert B again. So if I insert B again, now you realize the problem, right? कि जैसे B insert किया तो B को explore करते हैं, फिर से A explore, A हो जाएगा, A से B, B से A से B, B से, and our algorithm will keep searching, keep circling between A and B and will never reach. So we are exploring the, so we are exploring the same state again and again. So we are kind of repeating this state, which we kind of leads into the infinite search. So it might lead into the infinite search and never return a solution. So how can we solve this problem? So we'll solve this problem by maintaining another data structure called visited set. तो what will do, जैसे ही कोई नोड एक्सप्लोर होता है तो यहाँ पे जैसे आता है will add it to the visited set, एंड जैसे ही कोई नोड हम फिर से फ्रंटियर में इंसर्ट करना चाह रहे हैं will first check whether this is in the visited set or not, and then only will, अगर वो नहीं है then only will add into the frontier again. So let me show you an updated strategy. We'll start with the frontier containing the initial state only. So this frontier is known as open list, and will also maintain an empty explode set. Will maintain an empty explode set called close list, which will give us the frontier, or which will keep storing all the nodes which has been explored so far, right? After that, we'll go over with the same strategy of pick one node from the frontier, right? We'll choose one node. If we'll repeat the same strategy. The frontier is empty, then there is no solution because the goal is not reachable from the initial step. तो will return कि there is no solution. But अगर frontier is not empty, तो हम क्या करेंगे? We'll remove one node from the frontier, check whether this is a goal node or not. अगर goal node है तो we'll return that as a solution कि ठीक है, हमें goal मिल गया. We can simply find the path from starting step to the goal, and we'll return that as a solution. But अगर goal नहीं है तो we'll node add that node into the explode set ताकि उसको बार बार हमें explore ना करना पड़े. So we'll add कि ये node जो अभी हमने निकाला है that has been explored and added into the explode set. तो now that explode set में add हो गया, then we'll expand the node. expand node में मतलब all जो successors जो भी generate होंगे, तो जो भी successors generate हुए इनको फ्रंटियर में ऐड तभी करेंगे जब या तो दो वो फ्रंटियर में भी नहीं है, they aren't already in the frontier and the explode set. तो फ्रंटियर एंड एक्सप्लोर सेट दोनों में नहीं है तभी जाके वो फ्रंटियर में ऐड होंगे, ऐड टू द फ्रंटियर ओनली व्हेन दोज आर नॉट इन फ्रंटियर और एक्सप्लोर सेट, ताकि अगर कोई स्टेट ऑलरेडी एक्सप्लोर हो चुका है तो विल नॉट ऐड इनटू द फ्रंटियर अगेन. सो it will solve us the problem of repeating again and again. Okay, so that's it for this lecture. So this explored set is also known as a closed list in case you encounter with this name itself. So that's all for this lecture. In the next lecture, we'll talk about our first search algorithm called BFS, and so we'll start with the implementation of the frontier. We'll implement our frontier as a queue and search for the path or the solution in our set graph. Okay, that's all for today.